Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss the hot, wet equatorial climate system as discussed in G.C. Leong book. Here are all the climatic systems discussed in G.C. Leong book, and we have discussed one by one all of these climatic systems. So do watch all of these videos. Today we are going to discuss the equatorial system. Now G.C. Leong has not specifically mentioned which climatic classification system he has used. Therefore, we will be doing slight comparison with Köppen climate classification because this is the most accepted climate system around the world. And if we see both of these systems side by side, then we can see that there are slight changes in the area for a particular system. For example, here is the equatorial system represented in this color, slightly brown color. Similarly here, the brown color indicates the AF climate, which is similar to equatorial climate in G.C. Leong book. And we can see that the coverage area varies compared to G.C. Leong. Now, this is the equatorial climate which is discussed by G.C. Leong. It is in South America, where we can see there are two regions. Then it is in Africa on the western side, on the Gulf of Guinea region. And then we have the East Indies Islands. And here we can see this is the spread of equatorial climate in this region. Similarly, if you see the Köppen climate system, then these are the tropical climatic systems, and these are basically the four main classification of tropical system in Köppen classification system. Out of this, the AF rainforest is our equatorial climate as in G.C. Leong. And if you see the spread of AF rainforest climate system in Köppen classification, then we can see the spread is along the equator but slightly different than G.C. Leong. So do keep this in mind. Here we can see both of the regions in side-by-side maps. Here in the South America, this is G.C. Leong classification of equatorial system, and this is Köppen climate classification. So we can see the difference in regions in Africa. The West Indies Island is almost similar. However, the main difference is of Philippines Island, where we can see here we have Philippines Island where there is no equatorial climate, and here we can see in the Philippines there is some regions of equatorial climate. Now let's start with the G.C. Leong hot wet equatorial climate, and we can see in this map that the spread is between 5 to 10 degree north and south. So this is the Tropic of Cancer and this is the Tropic of Capricorn, and we can see that all of this equatorial climate is within this Tropic of Cancer and Tropic of Capricorn along the equator. Moreover, even it is safe to say that it is within 10 degree north to 10 degree south. So this whole equatorial climate is within 10 degree north and 10 degree south. Now there is some confusion in the map of G.C. Leong. If you see this map, which is for equatorial climate, here we can see that Thailand is shown as part of equatorial climate. But when we go to the monsoon or tropical marine climate, then again we can see that this whole region is shown as part of tropical marine. So, and if we see the text of tropical marine, we can see that G.C. Leong mentions that the tropical marine climate is experienced in Central America, West Indies, Northeastern Australia, the Philippines. So that is why we have modified this region and we have excluded this part and Philippines. So equatorial climate is seen in Malaysia, Indonesia, Papua New Guinea and other islands in this region in the East Indies Island except for Philippines. In Africa, we have Congo Basin. This whole region can be described as Congo Basin. Here is the Congo River which flows. And here is Gulf of Guinea. So we can also say along the coast of Gulf of Guinea, we have equatorial climate in Africa. Then here is Amazon Basin, and then here in the Andes, we have another region of equatorial climate. Now if you see the temperature characteristics, taking an example of Kuala Lumpur, which is in Malaysia, and it experiences equatorial climate, and it is a good example of equatorial climate. So if you see uniformity of temperature throughout the year, this is the temperature graph, and we can see the values of temperature in degrees Celsius over here. So we can see that it is almost constant, almost uniform throughout the year. The mean monthly temperature is around 27 degrees Celsius. Here also we can see that it is somewhere around 25 or something like that. Then there is no distinct winter over here. So we can clearly see that there is no distinct winter or there is no distinct change in the environment. Throughout the year, the temperature remains almost similar. The maximum daily temperature is 32 degrees Celsius and minimum daily temperature is 22 degrees Celsius. So the temperature remains within this region. Diurnal temperature range is small. Diurnal means difference in the daily maximum temperature and daily minimum temperature. So within a day, what is the maximum temperature and what is the minimum temperature, the difference is smaller compared to other climatic systems. It has low annual temperature range. What this means that maximum average temperature of one month and minimum average temperature of another month, there will be very less difference. So you can see here that almost flat line is there because the difference in the month having maximum temperature in the month having minimum temperature will be very less. Here we can see that the monthly temperature variation is less than 3 degrees Celsius. We can see that the graph is almost constant. So the difference between minimum and maximum of this graph will be less than 3 degrees Celsius. There is an example of Majuro in Marshall Island in Pacific Ocean which has variation only of 0.3 degrees Celsius. Another important characteristic is relative humidity is very high. It is greater than 80% throughout the year. And this we can see from this rain or precipitation chart that the moisture is higher than 80% throughout the year. And because of this we have a sticky and uncomfortable climate throughout the year. The climate is monotonous. We can see here there is no distinct winter over here and there is no distinct dry season in which there is no rainfall. So we can conclude that throughout the year the climate is monotonous. Now let's try to understand why there is uniformity of temperature throughout the year. The first important reason is cloudiness and heavy precipitation which reduce temperature. So here we can see that these are the wind systems, permanent wind systems, and these are the Hadley cells which is rotating like this. This is our equator and this is subtropical high pressure. Air from here is flowing towards here, equator. Similarly, in the northern hemisphere also air is flowing from the subtropical high pressure towards the equator, and both of these branches they meet over here and they rise up. Now because in this region there is a lot of moisture, remember the temperature is higher, there is ocean, there is evaporation. So there is moisture, this moisture rises with the wind and therefore we can see that there is distinct cloudiness in this area. This cloudiness is permanent. It remains throughout the year because this rising branch of air is also permanent. This is called ITCZ and it is a permanent region of rising air, that is permanent region of low pressure. So because of this we will see cloudiness throughout the year. Here we can see an image and we can see that in this region there is permanent cloudiness, and that is why we also see there is almost throughout the year rainfall in this region. Second important reason for uniformity of temperature throughout the year is regular land and sea breeze which makes the temperature equable. So during the day the land is warmer, the sea is cooler. Cool breeze it comes from here towards the land and it reduces the temperature of the land, thus making the temperature of land and sea almost equal, because warm air when it reaches over here it will heat this region and therefore we will see that both of these regions will have relatively equivalent temperature. And during the night land is cooler, sea is warmer, reverse thing happens, wind will blow from the land towards the sea, thus decreasing the temperature of the sea, because the air which is coming is cooler, it will reduce the temperature, the warmer air will come here, so it will increase the temperature of land. That is why the temperature remains relatively uniform throughout the year. Now let's see the equatorial climate in high altitude regions in the equatorial belt. There are certain regions which are having high altitude like the northern Andes in the South America, where we have Bogota which is capital of Colombia. It is located in northern Andes and here is the temperature and rainfall chart. You will see that the rainfall is lesser even the temperature is much cooler. Earlier we had around 27 degrees Celsius. Here we have around 15 degrees Celsius, but still what we can see that the characteristics is similar even though the altitude is higher. Here we can see that the temperature graph is almost flat and we can clearly see that there is no distinct month without rainfall and there are two peaks of rainfall. There are other highlands, Cameroon Highlands in Malaysia, it is in the equatorial region, it also has similar characteristics, and then we have Kenyan Highlands. Now let's try to understand the precipitation characteristics in equatorial climatic region. We can see that the precipitation here is very heavy. It is 150 to 250 centimeter, and we can see this by these charts. We can clearly see that these charts are present in all the months. There is higher rainfall, approximately 150 or above rainfall in each month. Therefore, there is no month without rainfall, and there is no distinct dry season. The rainfall is evenly distributed. We can see that we can draw a line. We can draw a line like this, and we will see that most of these charts or most of these months have rainfall more than this line. So we can see that it is evenly distributed rainfall. The difference is not very high for each month. Now, if you see, there are two periods of maximum rainfall peak in equatorial climate. This is a very important characteristic of equatorial climate. And to understand this, let's draw a line through the peak of rainfall in each month. When we will do this, we can see that we will draw this curve. And here we can see that there are two distinct peaks. One is right over here and another is right over here. So in these 2 months, we can see that here and here we have peaks, and it occurs in the months of April and May over here, and here we see it occurs in the month of October and November. So because of this, there are two peaks in the rainfall, and this is a very distinct characteristics of equatorial climate. So if you get this kind of chart and you see that there are two peaks, then you can directly say that this is a chart of equatorial climate. The peaks occur shortly after equinox. Equinox is the time when the sun is over the equator, and least rainfall occurs in June and December. It is the solstice time. This is the time when sun is over Tropic of Cancer or Tropic of Capricorn. We will see this later in this video. The double rainfall peaks on equinoxes is a distinctive feature of equatorial climate. It is not found in any other climatic condition. So this behavior, where we have two peaks, one over here and another over here, this is a very important characteristics, and it should be kept in mind. Now let's try to understand why there are double peaks of rainfall. Here we can see this is again the Kuala Lumpur rainfall chart, and we can see that here there is one peak and here there is second peak. So let's try to understand why this occurs. Now to understand this, let's try to understand the Earth's rotation around the sun. Here we can see three videos. The first is the side view. Here we can see the side view of our Earth when it is rotating around the sun, and we can see that there is this line which indicates the enlightened area and the darker part of our Earth. This line indicates the part of Earth which is directly facing the sun. Right now, sun is over Tropic of Capricorn. It is at the lowest position. This is December, and we know in December the sun is in the southern hemisphere. So this point is called December solstice, where the sun is over Tropic of Capricorn, and this is the front view. We are looking from the sun's view. So we can see this is Tropic of Capricorn. Now, as the Earth progresses in its orbit, it will move and it will change its position. And we can see the sun's position is also moving, and it reaches in March. Now here we can see that the sun is right over the equator. This position is called equinox. Now here is equinox of March. Similarly, when the Earth progresses in its rotation, it will move from this position towards here. In June, it will reach the furthest position in June. And now we see that the sun is over Tropic of Cancer. And this is June solstice. Similarly, when it will move further, the sun will move from here to this position. It will reach in this position by September. Again, the sun will move over equator. We can see that the sun is again over equator. Here we can see that the sun is over equator just below India. And this is again September equinox. So this is how the sun changes its position related to Earth's surface. Now, if we see in this diagram, we can clearly see the sun is moving. Along with the sun, ITCZ also moves. ITCZ is the intertropical convergence zone, where air from both the hemispheres meet and rise up. This area is cloudy. So we see that it crosses once, it moves down, and then when again the sun will move up, this ITC will again cross the equator region. So in a given year, the ITCZ crosses the equator twice, and that is why we see that there is increase in the rainfall twice, once in one equinox and second in second equinox. Here is the actual view of ITCZ. The ITCZ that we saw in the last image was a flat line, which is an idealized condition, but in real life the ITCZ is distorted like this red line, and the movement is somewhat like this. Here we can see that the wind is moving from both the hemispheres and merging at the ITCZ, and then it will rise up to give rainfall in this region. So as the sun moves, the ITCZ also moves, and we can see that it will cross the equator twice, giving equatorial region two peaks in a given year. So let's again summarize two periods of maximum rainfall peak, one in April-March and another in October and November. The peaks occur shortly after equinox. So remember, they just follow the equinox, they do not occur at the equinox. Less rainfall in June and December solstice, because at this time the ITCZ is either closer to the Tropic of Cancer or Tropic of Capricorn. Therefore, the rainfall within these times decreases. Double rainfall peaks on equinox are distinctive feature of equatorial climate, which we have already seen in detail now. So in this image we can see these are the positions of equinox and these are the positions of solstice. Now let's try to understand the type of precipitation that occurs in the equatorial region. Remember, not only single type of rainfall occurs, but three types of rainfall occur in the equatorial region. The first is the daily torrential showers that occur. So within an equatorial region, because it is on the equator, the sun is directly over it throughout the year. We will see that during the morning it is bright and sunny. Morning sun starts heating the land. We can see that the sun is rising and it is heating this land. As the day progresses, the land will get heated. The sun's energy till afternoon will heat this region, as we can see over here. Now once this land gets heated, what will happen? The wind will receive the heat and it will also start to rise up. Now because the air which is closer to this land, it has got heat from the land, it will start to rise up very fast. And as it rises up, it carries the moisture with it. And this moisture which is carried along with this wind, it starts to form cumulonimbus clouds. We can see these are the cumulonimbus clouds which give very heavy rainfall. The evening rainfall starts due to cooling of rising moisture. So now we can see that rainfall occurs in the evening because the moisture which has risen up by the upwelling wind, it causes cloud formation and then it falls down as a rain because it cools down in the upper atmosphere. So this process occurs daily. Now here in this chart we can see this process. Here in the morning time the air has started to rise up, then slowly more air has started to rise up. We see formation of this cloud and then the rainfall starts to occur and this cloud slowly dissipates in the evening. So we can see this is the whole process which is repeated almost every day. Therefore, the equatorial region has rainfall almost every day. Now, the second precipitation is because of ITCZ. We have seen that these are the two hemispheres and these are the trade winds. And both of these trade winds, they merge at the ITCZ. And the ITCZ, when this air rises up, it forms clouds and it gives rainfall in this region. And because the ITCZ is always very close to the equator, therefore a lot of rainfall here occurs because of ITCZ. Here we can see that there are intermittent showers from cyclonic disturbances caused by convergence of air currents in doldrums. So this whole region, this whole thin region is the doldrum region, and we can see there is continuous clouds which give rainfall in this region. Another region is orographic rainfall. So some of these regions have mountains, and when there are mountains, in this region, the air which is coming and it has moisture, it will rise up. And when it rises up, the moisture is cooled down. It gives the rainfall over here. Now, basic reason for rainfall is adiabatic cooling. The moisture which is rising up, it is getting adiabatically cooled because the pressure is higher in the flatter region compared to the pressure on the top of the mountains. And therefore, we will see that there is a adiabatic cooling of the rising air which cools down the moisture, giving the rainfall. And here we have adiabatic heating because the pressure increases as the air moves from this region towards this region. So this clouds will never give rainfall. Now, let's try to understand the equatorial vegetation, that is what kind of vegetation occurs in this region. So, first let's see what are the factors affecting vegetation growth. High temperature and high rainfall supports vegetation. So, we know that high temperature provides sufficient or better conditions for vegetation to grow, and there is also high rainfall. So, both of these conditions are good for growth of vegetation. Amazon forests has very dense vegetation and it is called selvas. Growing season is all year round. So in different climatic situations, like in the higher latitudes, we see that there is distinct growing season. Like there is spring season when trees grow, and there are other seasons like autumn when the trees do not grow much. But here there is no distinct growing season. There is no drought or cold to check the growth. So plants can grow throughout the year. There is no distinct seeding or flowering or fruiting or decaying period. One tree could be in seeding process, another could be in flowering, the third could be in fruiting phase. So all these distinct phases can be seen simultaneously in one place in the equatorial climate because there is no factor to check the growth or control the growth. Now, let's understand the type of equatorial vegetation. So first is that there is great variety of vegetation. We can see in these images that within a smaller area we see very distinct types of trees. Multi varieties of evergreen trees are there. Yield tropical hardwood. So the wood that we get from here are hardwood, and these are some of the examples of these kind of trees. Then we have smaller palm trees. Climbing plants are also there. So these plants, they climb on the branches of other trees. They are epiphytic and parasitic plants which grow on other plants, and then there are ferns, orchids and laurel grass type of plants. So we can see that very distinct atmosphere is there. There are very distinct type of species in a very small region, and we can see in both of these images that there is no single species of trees but multiple species of plants are there in a smaller region. Now there is distinct stratification of forest canopy. What this means that at the higher level we can see that there are certain type of trees, then there will be slightly shorter trees which will form the canopy. Then there will be third layer where we will see further smaller or young trees, and then at the ground on the floor we will see distinct ferns and other shrubs growing over here. So we can see that there is distinct stratification. There is layering of the trees or layering of the canopy. So we see very thick canopy formed by trees of various height. Tall trees form the topmost layer, smaller trees spread under the taller trees, and forest floor is covered with ferns and other smaller plants. So we can see there is distinct stratification. Taller trees, slightly shorter trees, young trees, and then we have ferns and shrubs at the ground level. Multiple species. Equatorial forests have multiple species found in one location. There are no pure stands of a single species. What this means that in the equatorial region, multiple species of trees or plants are found in a given region. They are mixed. Here we can see a temperate forest, and all these trees are of single species. These are called pure stands of trees. However, here in the equatorial region, we see that there are trees of one species, but they are mixed with other species also. And because of this, lumbering is very difficult. Here you can go and cut these trees, use their timber. But in this location, there will be small group of one tree, then there will be second group of other trees. So lumbering is difficult because if you want specific type of wood, then the trees will be located in different locations. Moreover, the hardwood does not float on the water. Remember, the equatorial climate, it gives hardwood types of trees and it will not float on the water. The temperate forest, they have single species occurring in an area. So generally we will find that the single species is spread in an area, and therefore it is pure stands are found. It is easy to lumber or cut them. Softwood also floats on water. So this also helps in transportation of these trees. Now in equatorial vegetation, we also see that there are secondary forests. What happens that because of shifting agriculture practiced by the nomadic tribes as well as lumbering, it creates empty space between the forest. Here we can see these are the forests, and by cutting the trees in this region, there was an empty space which was created. So over the time, secondary trees will grow in this region. So this is also seen. The secondary trees are less luxuriant, that is, they have less variety. They are generally shorter trees and dense undergrowth. But still, we see that there will be a secondary forest within the old forest if there was an empty area created by any factor like shifting agriculture or lumbering. Even in coastal areas, we see that mangrove forests could be found. These are the examples of mangrove forest. We can see these are the coastal regions. Now let's try to understand the life and development in the equatorial region. So these regions are generally sparsely populated because it is inhabited only by primitive people, hunters and tribes which have primitive type of living. The economic activity is mainly hunters and gatherers. So we can see these are the hunters and gatherers. They would either hunt animals or go and look for fruits because there are abundant animals, there are fishes, there are fruits. So they rely on these sources of nutrition. Forest-based activities is also performed by some tribes. Amazon Basin Indian tribes collect wild rubber. In Congo Basin, pygmies gather nuts and they sell it to the villagers. And in Malaysia, Orang Asli makes cane products and they sell it to the villagers. So we can see that some forest-based activities also performed by the tribe. Then shifting agriculture is practiced. What happens here? That you clear a region of the forest. Then you do farming in this forest for 2 to 3 years. Then you clear another area and you leave this area. Then vegetation will be formed in the older area, and when you are completed with this area, you will move on to another area. So this is what is shifting agriculture. It is performed because equatorial region has very less fertile soil. Therefore, once the fertility of the soil ends, they will move to another location. We will see why fertility is less in the later part of this video. So, shifting agriculture is practiced by the tribes. They clear field for temporary agriculture, shifting to another field after couple of crops. The examples are tapioca, maize, bananas, groundnuts. So these are the major cultivation done in these regions. Then, when the Europeans arrived in these regions, they started plantation work. And the most important was rubber plantation, which was most abundant. Malaysia and Indonesia are the leading producer of rubber currently. Brazil used to be the leading exporter earlier, but now it does not export much rubber. Cocoa is another plantation crop which is used for chocolate production in mainly European or Western countries. In West Africa, bordering Gulf of Guinea, we see a lot of plantation of cocoa. Nigeria and Ghana are the major producers. It is used in chocolate production in Western countries. Other important plantation crops of equatorial region are palm oil, coconut, sugarcane, coffee, tea, tobacco, spices, bananas, pineapples, chincoa and sago. So all these are also important plantation crops. Now let's see the factors affecting development of equatorial region. So the first is excessive heat and humidity. And because of this excessive heat and humidity, there is serious physical and mental strain on the people living in this region. There is continuous precipitation. You are always losing your moisture. You are always sweating. And because of this, you always feel tired. There is loss of energy. Sunstroke can also occur because sun is always overhead in this equatorial region. Vector diseases is also much prevalent in the equatorial region. Malaria and yellow fever are few vector-borne diseases which are prevalent in this region. We can see that most of these are concentrated in the equatorial region and regions closer to it. Because of these challenges, work and accommodation are very difficult for people who have to work in this region. Then there is hot and wet weather, which promotes insects and pest growth. So germs and bacteria also are easily transmitted and they easily survive in this climate. Insects and pests grow rapidly in moist environment, and they not only cause disease but also harm crops. So we can see that they directly affect the health of the people living in this region as well as they damage the crops. So these pests and insects are also one of a problem because of which agricultural activity is not flourishing in this region. Now, dense forest hinders development because it is very dense. It is difficult to clear an area and keep it that way because there will be quickly undergrowth. There will be trees or secondary grass or secondary trees will be formed in this region. Due to high density, difficult to clear and maintain a small land, tall grass and thick undergrowth soon spreads the region. We can see that even if you clear an area, there will be undergrowth, there will be small plants in this region. Rails and roads are difficult to be constructed across forest. Why? Because there are swamps, dense forests. It is difficult to make railways in this region. Even the building crew faces wild animals, insects, snakes. So there are various problems for the people who are maintaining this land. Even once the region is constructed, once the project is completed, maintaining it is also a difficult and costly work. Therefore, many equatorial forests lack road connection and only rivers are used for transportation or communication in this region. Then another cause which affects the development of equatorial region is rapid deterioration of soil. The equatorial soil is poor in nutrients because there is so much of rainfall that all the nutrients which can dissolve in water, they are removed away. The soil is heavily leached soil. So the heavy rainfall removes most nutrients. Only nutrients come from humus. So humus are the fallen parts of the trees and plants. So these are the only nutritious things in this soil, and these are easily depleted. So once humus consumed, the soil becomes infertile. Therefore, it is unsuitable for agriculture. Java Island is an exception because of the volcanic soil, and that is why in this region there is shifting agriculture, because the humus content of the soil will be depleted in one or two crops, and once it is depleted, they have to move to another region. Then we have seen that there is no lumbering activity in this region because even though the tropical forest has huge timber resource, lumbering is uneconomical because no pure stands of single tree species is there. Tree species are generally mixed. Therefore, it is difficult to lumber or cut down trees of one species. Hardwood does not float on water, and dense forests make difficult to transport. So even if you cut the wood, it is very difficult to transport. Here in the temperate region, we see this is the softwood, and this is how it is transported by river. So see, it is very cheap way of transporting wood in the temperate regions, in the higher latitudes. But in the equatorial region, we see that the wood will not float, it will sink in the water. And because of its high density, transportation or building roads is also difficult. Then no livestock farming. We see that livestock is also difficult to maintain in the equatorial regions because there is high density of forest. The grasslands are none, or even if there are tall grasses, then they are not sufficient nutrition for cattle in those tall grasses. Domesticated cattle are affected by insects and diseases. Tese flies cause deadly disease in the equatorial region. So because of the high amount of pests and insects and bacteria which are found in the equatorial region, even the animals or the cattle are not safe. They are easily infected. Equatorial cattle are also less productive than temperate cattle. They are generally used as beast of burden. So we also see that the cattle in the temperate region have higher value. They will give you more returns, whether it will be in the form of milk or other purpose. Here the productivity of the animals is very less. So here we have completed all the topics discussed in the equatorial climate of Leong. I hope you have liked this video and do watch other videos on other climatic regions. Thanks for watching the video, and if you like the video, then do share it with your friends and subscribe to the channel. And if you like what we are doing, then you can support us using the Paytm ID. Thanks for watching the video.